Welcome to the third video for this lesson. Today we're going to be doing chapter 2, but we're going to be doing section 3. So again, remember we're skipping around on this chapter. We are in section 3, elements and compounds. We start this section by first talking off about what is a substance. I've been using this word a lot in class, so we're going to actually define it because it becomes important for this lesson. Substance is matter that has uniform and definite composition. So let's break this down. Matter. Remember, matter is anything that has mass and space. So remember that. We had anything that has mass and takes up space is considered matter. And it's matter that is uniform and definite, which means the composition does not change. If we're going to talk about a substance, it's always going to be that. So for example, when I'm talking about aluminum, it's always going to be made up of aluminum atoms, nothing else. If I say copper, it's always going to be made up of copper atoms. And these are really two good examples, and these two we're going to learn that in the next slide that these are considered elements, and they're referred to as pure substances. So substances can be classified two different ways. The first way is as an element, and the second way as a compound. And we're going to talk about each of these separately so we can define them for you. So an element is the simplest form of matter, and it has a unique set of properties. So I like to tell people that an element is made up of one kind of atom. So for example, oxygen is only made up of oxygen atoms. You can have a million, you can have a billion. No matter what, as long as it's one kind, it's an element. Hydrogen is an element. And you might recognize these from junior high or just talking about them in science class. But elements, all known elements, are located on the periodic table. And we're going to talk about the periodic table briefly tomorrow. So they're located on that periodic table. Okay. So substances, like we said, we talked about elements, but now we're going to hit the second part, compounds. A compound is a substance that contains two or more elements chemically combined in a fixed proportion. Let's break that down. It has two or more elements, or I like to say two or more different atoms. A common compound that you guys might know is actually H2O. So if you had water, H2O, it is made up of two elements. It's made up of hydrogen and oxygen. So those are the two elements, and they're different. The other part of this is chemically. So that means they're fused together. So not physically, because physically is used to describe something else. And the last part is a fixed proportion. So when something is fixed, we're going to talk about this on the next slide, it means it's the same every time. Same every time. So here's an example we're going to talk about through fixed. Carbon, oxygen, and hydrogen are all elements. You can find them on the periodic table. Carbon's represented by C, oxygen's represented by an O, and hydrogen by an H. What happens is these chemically combine to make a compound known as sucrose or table sugar. So in fact, to get table sugar or sucrose, you have to have 12 carbon, 12 carbon, 22 hydrogen, and 11 oxygen. So those combine to make sucrose. And here it says every sample of sucrose, there are twice as many hydrogen than oxygen. So if you look at the number for oxygen and hydrogen, you can see that yes, hydrogen does have twice as many. Because if you took 11 plus 11, you are going to get 22. This proportion of always having 22 hydrogen and 11 oxygen is considered fixed. It does not change. It's going to be that way every time. So what are other ways that you can help determine the difference between elements and compounds other than looking at how many atoms make it up? The key difference between elements and compounds is, can they be broken down? Compounds can be broken down by chemical means. And the reason they have to be broken down by chemical means is because they're chemically combined. Elements cannot be broken down. So compounds can be broken down. In fact, they can be broken down as either one into elements, or they can be broken down into other compounds. And we're going to actually look at that and see that coming up here soon. Elements, remember, cannot be broken down. So here's where we're going to talk about physical versus chemical again, just so we're clear. Remember, breaking down compounds, you can only do it chemically. So that means things that are physical cannot be used to break down simpler substances. You might ask yourself, what are some examples of physical methods? So if you ever boil something, that is considered physical because it is a change in state. If you boil water, you're going to get water vapor. It doesn't break down into oxygen and hydrogen. So water is still water. Another example of physical is dissolving. So remember, we talked about this in other videos and in class. You dissolve something, it is also physical. If I took sugar or salt and dissolved it in water, I'm still going to have sugar or salt. It does not break down. You've probably heard of sugar water. You can actually boil that water off and get your sugar back. Now, this doesn't mean that we can't break down these things. What this means is that we have to use chemical changes. So let's go back and define what a chemical change is. So a chemical change is a change that produces a different composition or a different makeup. We talked about this before, so let's review. What are some clues to help tell if something is chemical? One of the clues is a color change. The second clue is formation of a precipitate. And if you forget what a precipitate is, it is a solid that comes from a liquid mixture. The third thing is bubbles, or the production of a gas. And the fourth thing is a transfer of energy. And remember, if you don't remember this, go back to that video. A transfer of energy can be seen two ways, as heat or light. So it's heat or light. So a good example that your book likes to use, and this is going to be a question on your worksheet, is one way to break down compounds is heating it up. So heating, remember, is a transfer of energy. Here we have sugar, and it's the heat from the stove, or the energy from the stove is being transferred to the sugar. The heat's being transferred. Eventually, the sugar is going to start breaking down, and when it breaks down, that hydrogen and oxygen inside of it is going to make water vapor. And this water vapor is going to keep going out into the air, going out to the air, till eventually the only thing left behind is some carbon. So here we have carbon left over, and hydrogen and oxygen went into the air as water vapor. So here is a slide that kind of breaks down some of the topics we've been covering about. It says, can the substances that are produced when sugar is broken down also be broken down? So sugar, we saw that it breaks down into carbon and water vapor. So we have to actually look at these two things. Well, can carbon be broken down? Here we're going to see that says no. We cannot break down carbon, and that is because carbon is an element. If you look on the periodic table, you will see carbon as an element. However, water vapor, remember water is considered H2O. It is considered a compound, and remember, compounds can be broken down further. So in fact, water can actually be broken down into some hydrogen and some oxygen. But how? Let's take a look. So right here is a good picture. Sugar, which is a compound, if you heat it, it becomes carbon and water. And we want to separate that water even farther. So when an electrical current passes through water, it can actually separate into hydrogen and oxygen. And electricity is another example of a transfer of energy. If you electrocute something. And the reasoning is actually when I electrocute water, these two elements get a charge, and it causes them to be attracted to whatever you're putting into the water to cause the electric current, and they separate based on if they're a positive charge or a negative charge. This is the last little section I'm going to cover. I had to split it up in class, and it's going to be about talking about properties of compounds. So remember, properties are things you observe. They can be chemical properties or physical properties. For example, you can observe color is a property. Things like shape, smell, taste, state of matter. We talked about intensive and extensive. So you have things like mass, volume, density. Some that you may have learned in integrated science is hardness, malleability, so how well can it bend, things like that. So in general, properties or things we use to describe compounds are not the same as when we describe the elements that make them up. So for example, sugar is again made up of 12 carbon, 22 hydrogen, and 11 oxygen. So this is what sugar is made up of. And sugar is sweet tasting. It's white. It's a solid. However, if we look at the carbon that makes it up, carbon by itself is actually tasteless. It's black and it's a solid. Thank goodness that when carbon pairs with hydrogen and oxygen, that it creates something that is very sweet tasting and delicious. And I don't know how anyone could live without sugar. Another example is hydrogen and oxygen. So if we were to talk about the properties of an element, hydrogen is considered a gas that burns if oxygen is present. And oxygen is also a gas that helps keep things burning. That's why when you light a candle, you have to have the lid off it so oxygen can reach it. Funny thing is, if I take this hydrogen, and I combine it with an oxygen, it's going to create water. And this product can actually stop things from burning, and it's a liquid. And that's nothing like what it's made up of. The last example that we use of this is sodium is an element. and it combines with chlorine. So sodium is represented by Na. It combines with chlorine to make sodium chloride. So these two things combine to make known as table salt. So let's look at the properties of each of these. Sodium, the properties is a soft gray metal. If I were to look at what chlorine is, it's a pale yellow poisonous gas. So it's poisonous. You can't eat chlorine. Yet, chlorine is found in table salts. And the reason is because when you combine those two elements, you get sodium chloride, or you get a white solid that is edible. So thank goodness, if you combine two things, they create whole new properties. So not only do you get a whole new substance, but you also get a whole new set of properties. So if you do chemically, there's a change in composition and a change in properties. So this is our ending question that I'm going to end on. Can elements be broken down by chemical changes? If you had said no, you are correct, because elements cannot be broken down any further. If you say compounds, yes, only chemically though. Remember, not physically. So yes, compounds can be broken down. We talked about sugar being broken down, and we talked about water being broken down. So that kind of ends today's lesson. If you have any questions, please do not hesitate to email me, and I will help you the best of my ability or describe something in a different way. Have a good day.